Hello humans, welcome back. Today we'll be talking about rigging and joints and the skeleton and all that fancy stuff. Now, as I've noticed and mentioned in the previous video, the concept of rigging and adding joints is quite simple. You basically add a couple of points here, you tell Maya how much influence each point is going to be in, and then every time you move the point, you will have no problems. But before we begin, we should probably actually get the menu out. So I'm going to grab this and pop it off and put this over here. So let's start from top to bottom. Now, first and foremost, your bread and butter here is the Create Joints tool. You can open it up with the joint tool settings, which are quite extensive and have the orientations here. Now, we're not going to be talking about these orientations just yet, so we're not gonna bother with this stuff just now. You can also set up the radius for your long bones and short bones, etc. But we're not going to have any of these, so I'm just going to close that. I'm going to make a couple of bones, and I'm going to do this in the, well, I don't know, in the front view. So I'm going to grab a couple of these bones. I'm going to set it up in this weird fashion, and this will be our joint chain. As you can see, this could be a spine or something of the sort, but it's definitely not ideal because we are actually already having some problems. In our case, our root here is aligned in the wrong way. So if we start to rotating, we could actually rotate it properly, but the x-axis is pointing properly. Anyway, let me just explain this real quick. Once you have a chain, let me just hide this for a second. Once you have a chain, maybe I shouldn't have hidden it. Let me just grab it again and unhide it. Or I'll just keep it hidden, whatever. Once you have a chain, you need to start and think about how you're going to be using it. Okay, let's go through all these controls real quick to see how exactly this works. Now, the insert joints is quite simple. Essentially, select a joint and you click on the. Well, you don't have to select the joint apparently. Basically, you click on insert joints, you grab one and you drag it off, right? And then you grab one more and you drag it off again. And anytime you grab a joint, this will create an extra joint chain. Now this is quite simple to understand, so there's not much to it. The mirror joints is very simple to every other mirror tool. You basically select joint chain, select the joint chain. I think you can select the whole hierarchy, select all, and then you mirror the joints. You can mirror it across a different axis, and you can obviously mirror it. But then in our case, we don't actually have anything to mirror across, so there's really no need. In this case, you only need to grab the root, by the way. And there we go. We just mirrored it across this axis. But there's really no point in doing this right now. Like you could imagine that if this was an arm, something like this sort, and then we mirrored it, it would go across the other side, right? Then we got the orient joints, which we're not going to talk about just yet. I'm going to talk about these remove joint, connect joint, disconnect joint. These essentially work. They work everywhere, but they're basically made for when you have it already bound to your skin mesh. So if we were to go and unhide this, show. How do I unhide this again? I forgot how to unhide this. Oh, there, just H. If we were to unhide this, essentially, you would have a well, how should I explain it? You basically have two ways to work with this. If this was bound to our player character, so if we bind the skin, like I showed in the previous video, you actually have to unbind it if you want to change something in the skeleton most of the time, right? If you want to delete a joint, add a joint, do some fancy, because once you bind it, the skin weights will be working on these joints, and you can't just like insert something or connect a joint. In this case, these three tools, they work in the mesh bound skin mode, so you don't have to unbind it most of the time. Obviously, to insert joints, I believe you still need to unbind it. But things like connect joints and remove joints, disconnect them, they all work. As you can see, I've just disconnected our joint chain, but I'm not going to do that. This is essentially, you can also unparent this and it will also be disconnected, but it won't have an ending joint, so you'd have to add another joint. So it's handy in some cases. All right, the next is the handle tool. The IK handle tool is quite simple. You basically select, click on it, select the root of your object and then select the IK handle. Now, this is called inverse kinematics. In other words, instead of rotating every single time, every joint whenever you want to rotate it, this will give you an opportunity to basically tell Maya where you want your final joint to be, and it will move the rest of the joint chain based on math. Basically, it will calculate everything that needs to be calculated. So we click at the bottom, click at the top, and then we have an IK handle. Now this IK handle works quite simple. It has a pull vector which essentially points to which way is up. All right, so in other words, if we go ahead and straighten this out to the max, you can see that currently all of these objects are aligned. However, if we pull it back down, it's going to go back into this direction because it's across, like this is your plane vector, right? It's basically saying, right, everything you do will be on this plane here. It'll be on this frontal plane here. It won't be in any other direction, okay? So essentially, you could always go ahead and if we open up our channel box, we can change the orientation of the pull vector, right? As you can see here, and this will basically move our chain in different positions. Now, this is not an ideal modification. You could also go into your attribute editor. You could change the pull vector from there. I believe if we go into pivots, local space, no, where the hell is that thing going? Oh, there we go. There's your pull vector. There's obviously different solvers. So you got rotate plane solver and single chain solver. The single chain one does not use a pull vector, I believe. Yeah, so that's quite handy. In other words, it allows you to, it's like for an arm, right? I don't think it has a pull vector. Does it have a pull vector? It still does. Imagine that. Oh, no, it doesn't. So no matter how much you change the pull vector for it, it's not going to take it into account when you're doing your calculation. After that, obviously, if you go into rotate plane, you have your pull vector back. And that's that, essentially. Right. Well, that's all that matters for the IK handle. However, there's one more thing that we need to address, is that you can't really rotate it. There's no need to rotate it. But it's very small. As you can see, it's kind of hard to select, right? If you focus on it, if you got some mesh on top of this joint chain, it will be quite difficult to select this handle. So at the end of the day, you'd still need a controller for it. But I'm going to go ahead and delete this for a second. I'm going to go and create let me just rotate this. I'm going to go ahead and create an IK spline. Actually, before I do that, let me just walk you through the settings for these joints. If we go into Windows, Settings and Preferences, and we go into Kinematics, this is where you can adjust the size of your joints. Obviously, you can do that in the tool settings once while you're placing the joints. But it's still nice to have this thing around so that you can adjust the joint size, the IKFK joint size, and the handle size once you have them. Also, when it comes to color, there's two ways to add color to your joints. First one would be, well, there's three ways actually. So one would be to select the joint and go into Attribute Editor, and then once you go into Drawing Overrides, you can enable the Drawing Override and change the color of the joints, which we're not going to do. Another option would be to go into your Windows and Preferences and go into Color Settings. Then this will enable you to set up the joint color. So right now my default joint color is dark purple, but you could set it up to anything you want, like anything really, whatever floats your boat. I'm gonna stick to I don't know, cyan maybe, or yellow, or whatever. Where's my purple now? I don't have the purple. There we go. That's dark purple. Maybe that's not the best color, but hey, who cares? So this is how you change the color of your joints. The third and final way would be to create a layer, and we call this layer joints. And let's say we want our joints to be red, and we click the color of the layer to be red. Select joint chain, right click on the layer and add selected objects. And as you can see, our joint chain is now red, basically signifying that it is part of the of this red layer. All right, I'm going to delete this layer because we're not going to be using it just yet. So that's basically what it is when it comes to our joints. Now, aside from the IK, which is, like I said, inverse kinematics, essentially tells Maya to calculate. It's like a string, right? This is IK, the handle is IK, and this is FK, like I already explained in the last video. But just to reiterate, there's two modes of transforming, and you can blend between the two. Now, I haven't done that because I never had to. I think it's quite an advanced thing to have. You know, fully rigged with IK and FK characters are quite rare in games, unless it's some AAA stuff. But you can obviously go for it if you wanted to. The other thing is very important is the IK spline handle. Now the spline is a little bit different because it allows you, unlike the IK handle, which like I said goes from root to top, like from beginning to the end of your joint chain and basically controls your whole joint, right? Your IK spline handle, on the other hand, if I can select this and delete it, the IK spline will create a curve along your joint chain and allow you to basically move each joint depending on how basically each vertex. So if we go again and select these, go create an IK spline handle from here till here, you will notice that now we have a spline curve. Now the spline curve here is essentially a regular curve. So if we just show only the curves, let me just see, display, show none, and show only the NURBS curves. Wait, where is it now? Show, where are you? IK handles, deformers. I believe it's a deformer. No, maybe it's an IK handle. Yeah. So no, this is just a handle. We want the curve. Come on. NURBS curves. Yeah. So this is our curve. And as you can see, we can actually select this curve and go into a control vertex. Curve point? No, control vertex, I believe. And this should allow us to select it once we actually take a look into our CVs. There we go. So these are our CVs. For crying out loud, let me just show everything. So now that we have our CV selected, I can select this CV and I can move it. And based on this CV, I can actually deform this object. Now you can obviously add more CVs if you wanted to. You can select these two CVs and maybe create some fancy maneuvers, as you can see here. The IK handle will work in another way. You cannot actually move that. It's completely frozen. So your control is limited to the CVs here and to this object here. So this is a spline curve, which is quite handy when it comes to, you know, when it comes to your, like if you had something like a snake, because this will allow you very easily to modulate how your object will look like when you start, you know, deforming it in a different fashion. So it's quite handy, and ideally you'd want to have a cluster for this with a locator or with something like a controller. So in our case, we'd probably select these two vertices, and then we would go ahead and create a deformer, which would be a cluster, and then you can move this cluster and rotate this cluster to create different spine effects or different what's its face, snake effects, right? Anything really that you wanna be doing. Now I'm gonna go ahead and delete these because this is really not what I want to be doing. I'm gonna grab this handle as well and delete that. And I think I should delete the curve too. Oh no, it's gone by default. Okay, so the whole thing is gone. Let me just open the, yes, everything is gone. Okay, now these two controls here, you can actually set the preferred angle and assume the preferred angle of your joints, but this is where things become a little bit more complicated. We're not going to go over the quick rig or the human IK, and these enable, disable IK handles, etc. They're fairly self-explanatory. So we're not going to go over these. The preferred angle is essentially how you want, it's like zeroing out your joint. Okay, so basically it's like this is your zero instead of freezing the transform. But this is not something that we're going to talk about just yet. The more important bit is to take a look into our joint orientation. Now these orientations, as you can see, each joint has its own local axis, and these axes they point in different directions. So the thing is, every time you want to rotate a joint, you actually be rotating it based on its own local axis. So if I go ahead and grab this right now, you can see that it is like this has, I'm currently rotating it in the axis of the joint. But if I were to select these, all of them, right? Like select these 3 joints, and I start rotating them along the x-axis, you will see that the rotation does not have anything to do with, like the rotation is not that good because there's problems, all right? In other words, if we take a look here, the x-axis here is pointing that way. Here it's pointing upward. So if I start rotating on x and I rotate it by a particular amount, you will see that they're rotating in different directions because, as I said before, the orientation is quite weirded out on this. Now this is going to create a lot of problems if you don't sort this out of the get-go. So you really need to start and set up your joint orientations properly. I'm going to go ahead and select all the hierarchy here. So this is all of the hierarchy, including this, right? And I'm going to go ahead into display, show local axis. Where are the local axis now? Show sectional surfaces. Oh, there we go. No, I want to show geometry. No. Where the hell did the axes go? This used to be the place where you have the axes. Transform display, local rotation. There we go. My bad. I'm sorry. Okay, so as you can see here, we've got the Y's pointing fairly correctly in the right direction. All of your Y's and Z's are pointing correctly. Oh, and the X's are pointing correctly. Oh, this is quite weird. This was not like that before. I believe we were just checking out our joint chain. Things were quite different. There's definitely a discrepancy here. I'm not sure why this is happening because if we take a look here, this is correct. This is correct. Well, no, actually this is not correct. As you can see, the x-axis on this thing is pointing upwards, but then the local one is pointing correctly. So I'm not too sure why that is happening. Maybe this is the world orientation. I'm not too sure. But it is, they're pointing correctly. What a pleasant surprise. As you can see, the axes here are totally different if we take a look on these. Okay, so let's go ahead and select them again and see what happens then. Select this bit, and then select this joint, this joint, this joint, and that joint, and let's rotate them along the x-axis. Well, what do you know? They're all working fine right now. Just quite weird. Because if we notice here, this x-axis that we're looking at is pointing that direction. And if we rotate in the plus, here, this should be rotating our joint chain over here, like so. Like so. Which it doesn't. So I'm not too sure why this is happening. I thought that'd be, maybe there's something wrong with the rendering, I don't know. But they're all correctly. At the end of the day, the most important thing you want to see here is that all the time the x-axis of your joints points to the parent joint, right? And you want all of your secondary axis of your joints to be pointing in the same direction. So if I were to rotate in Y and I go, let's say, plus 90 degrees in Y direction, this would actually rotate all of the joints in the correct direction. So this is quite handy when this happens. Usually Maya screws up when you insert joints. I think they may have updated the algorithm because anytime you insert a joint, this usually creates a problem, but imagine that. Actually created an extra joint. Imagine that. Look, it's all correct now. Wow. I'm actually impressed. So there's nothing to do here, but at the end of the day, if you find yourself with a problem where your joint orientation is off, obviously this is where the Orient Joint tool comes in. So you'd be selecting, essentially, you select all of your joints. You go into select hierarchy, because if we take a look here, we've got quite a lot of stuff. And notice that, by the way, if I select just the bottom bit, this does not select everything, okay? So you have to select the whole thing. And then we would go into Orient Joint, And here, the important thing is to orient it in the right direction. So let's say you wanted your secondary axis, which in this case is y, to be orientated not in the plus, but in the minus. So you could always say, all right, I want to orient this to the minus, and this would be just fine. So after that, you click orient or apply, and this would solve most of your problems. At the end of this joint chain, this joint here, it'd be nice to have it oriented along with the bottom joint here. So I've selected these two right now. Would be nice to have it orienting it to the world. So if we click apply now, this should orient it to world. What? This did not happen that way. This did not orient it to world. Why didn't it do it? Orient to world. Okay. Well, that is quite weird. Well, at the end of the day, you can always go and do this in the attribute editor. So you go into the joint and go into, forget about draw outlines, forget about display, joint, and then you go into joint orient and just zero this out. And this is your world. I believe this is how it's best done. This was zeroed out already. However, this will create other problems. So you have to zero this out through a freeze transform. I kind of thought. Or you can actually set this as a preferred angle, and this is going to do it like that. Set preferred angle. This is a preferred angle, and then it should be 0, I believe. This should zero it out. Select the joint. This should definitely zero it out. I'm not sure. What if we freeze the transform here? Just the rotation. Yeah, so now it's zeroed in. So this is your default. But like for some reason, this does not go, this goes, gives me the local axis instead of the world axis. Not too sure why this is happening. But at any rate, this is a minor concern here. Like the bottom at the top here essentially are, they're rotating correctly. So as long as that's happening, you're just fine. Your X and Y and Z are working correctly, and at any rate, you probably have another one which would be separate, which would be something like if we go and create another joint over here, right? And then as you can see right now, it is set in the middle, and then we select this joint and that joint, and this would be your parent. Well, yeah. So this would be your parent. So this would be your parent, and the parent would be with a, there we go, straight joint. So yeah, this would be the end of the day, how you'd be doing it, how we go around it. We can always obviously just remove these, and that's what we're going to do, actually delete them. But I hope you understand how the joints work. I hope I don't get it too confusing with the local rotation axis, but let me just illustrate this one more time. Essentially, the idea is that rotations should be equal for every joint in the joint chain. In other words, right now it's going to be for X. You can set it up for anything else, but X is usually best. As you can see here, we have a discrepancy with our joints because this should be pointing, the X on this joint should be pointing to the X of this joint. So if we select this joint and we go into orient joint and we press orient, as you can see, let me just close this. As you can see, the change has been quite dramatic in terms of application because this will enable our rotations to be a lot more accurate. So if we were to rotate on X right now, notice how it's rotating along X. This is not what we want to be rotating along, all right? You want to be rotating along this axis here. So what you're going to be doing is, once you rotate this, let me just exit this too, my bad. Once you rotate this, now your X rotations will be correct. Okay, notice how it's rotating along the chain of command here. So that's basically the reason why you want these local axes to be aligned properly. And you want to do this before you start adding any handles, all right? Before you start adding anything specific. The last order, by the way, here of on the agenda here is basically our rotation order. Okay, so you have a rotation order. In other words, when you have an IK handle, I'm just going to open up the attribute editor. We go into our I think I need to expand this a little bit because this is starting to get quite cramped. So if we go into our transform attributes, you have a rotation order of X, Y, Z. So X goes first, Y is second, Z is final. This has to do with, like, you can always achieve basically a gimbal lock by mistake. I think this is the whole idea behind it anyway. So depending on how your rotation is going to work, you can set it essentially on, like, each different joint can have its own different rotation order. But you could always obviously just select all of the joint chains here. And set it up for all the joints. Okay, but at the end of the day, just make sure that you understand the rotation order is quite important, because it basically works on once you rotate something, which of these axes is going to be rotating first, and this is to avoid gimbal locks if you receive a gimbal lock. And a gimbal lock is basically something where you have a rotation on one axis, however, it also rotates on another axis. Let me see if I can achieve this here. This basically means when two axes align. So if we use the X first, like so, and then we use it like that, and then like that, you would have a problem. There was something like that anyway. The gimbal, you can always Google what a gimbal lock is, but essentially, what if you rotate an object that's like has a particular point, and then you rotate it in a particular fashion, these two of these axes will align to each other, and once you rotate one, it will also rotate the other, which is a problem. So that's why you have this XYZ rotation order. Anyway, guys, I think that is all I have to say here about joints and rigging. The preferred angle and the assumed preferred angle, these are, I don't know, bonuses, I think. I don't even know why they're there, because they're not zeroing out the rotation. But it's nice to have them around. Obviously, you have your IK handles and all these other controls here, but I believe it's as much information that you need. The quick rig and the human IK options are quite extensive. It basically allows you to have, once you have a humanoid with a bunch of bones, so we could have finger bones, wrist bones, right? You'd have joints on your elbow, on your shoulder, the head, etc. You'd be using the human IK because it's way easier to use, as in to make a rig. If you have, though, something like a dragon, you're kind of stuck, because a dragon is not a biped, and you'd have to create a rig for it, from scratch. In our case, we'll be creating a rig for our worm here. Okay, in the next video, I will create the rig, and then we're going to be talking about the skinning bit. So if we go here into skeleton, we've done that. Next, we're going to talk about skinning. So I'm going to go ahead and either create a rig right now or create a rig in the next video or between the videos, because with all of the stuff you've seen so far, it should be easy enough for you to figure this out. Okay, the skinning bit essentially is the menu set for binding this mesh to the particular joint chain that we're about to create. This will allow us to set up proper deformations and make sure that our final result is not a big mess. Okay, anyway, I'll see you guys next time, and experiment with the joints, just play around with them, see how local rotations basically could dramatically change your progress, because there are times where you might have a rogue joint, and you already have it all rigged up, you'll have it set up already, and this will create a huge problem, because you're going to have to realign the joint, or God forbid you have to like unbind again and then create another joint, and then you have to like start the painting weights. It's just ridiculous. All right, anyway, I'll see you guys next time when we start talking about the skins. Bye bye.